A little while ago I posted a video about a collective I've built and it generated a lot of interest, with some people requesting some more detail on how it's put together. Because of me moving shortly after the first video, it's taken a bit longer than I would have liked, but here it is. In this video I'll cover two subjects, the mechanical working of the collective and the electronics. The housing is made out of 12mm thick MDF. Inside of it you can see the pot meter attached to the main axis of the collective, the counterweight and the dampener. I'm using a motorcycle steering wheel dampener here, and it still has a little bit of stiction which I need to fix. Surrounding the inner PVC pipe collective arm is a water tube forming the throttle, and at the end is a 3D printed collective head housing the electronics. My electronics consist of an Arduino Nano clone running MMJoy 2, a fairly simple and versatile firmware for making custom HID devices. In order to be able to use all the buttons with a limited amount of readable pins on the Arduino Nano, a button matrix is used, which can be a little confusing if you don't have any experience with electronics, but it's well explained in the MMJoy GitHub wiki, of which I'll put a link in the description. The Arduino Nano has a built-in 10-bit analog to digital converter, allowing it to measure the position of a potentiometer ranging from 0, where the resistance would be 0 ohms, to 2 to the power 10 equals 1024, where the resistance would be at its maximum, in my case 10k ohms. The problem lies in the fact that most potentiometers have a mechanical limit of 270 degrees, whereas a collective usually has a travel limit of around 50 degrees, meaning that unless your pot meter matches this, you're going to lose on your final resolution. After some searching on AliExpress, however, I managed to find a 50 degree 10k ohm pot meter, and the problem was solved. Since the last video, I've also added an 8-way hat switch. I still have to find a hat that resembles the one found in the Huey, but for now I'm using a hat from a Logitech joystick. I've still got the dampener friction to fix, but a user from the Eagle Dynamics forum suggested me to replace the oil inside the dampener, so I'm going to try that in the next few days. I also still have to fix the throttle axis and finally give the whole thing a nice paint job. I hope this video answered any questions someone still might have had about this project, but of course feel free to ask your question in the comment section. And if anyone's interested in building one of these yourself, I've uploaded the CAD files and put a link in the description. Thank you very much for watching, and if you'd like to keep updated on this project, feel free to subscribe to my channel.